Now let's look at an example. Here we have a company called Chemetech, and they produce filtration systems, and they are considering three different production methods: method A, method B, and method C. See, these methods differ in the sequence of steps, so the company wants to determine whether any one of these methods is more productive than the others, or the productivity of all the three methods are the same. So the employees in the plant were considered, and randomly we select 15 employees, and of those 15 employees we randomly assign, so each of the three assembly methods is randomly assigned to 5 employees. So you take 5 randomly you select 5 out of these 15 and assign them to method A, 5 to method B, and 5 to method C, and then you measure the productivity coming from those 5 employees in method A, 5 in method B, and 5 in method C. And this table gives us the actual production observed from the 5 employees assigned to method A, 5 employees assigned to method B, 5 employees assigned to method C. So now let's look at what the response variable, factor, and so on are for this example. Okay. So here we want to test the productivity of method A, productivity of method B, productivity of method C. So these are the three different populations, and that's the factor, the method of assembly. The assembly method is the factor, and the treatment are the three different assembly methods, A, B, and C. So three treatment levels for the factor. The response variable is the measurement that we make, and that's your productivity, the number of systems assembled per week. So that is our dependent variable. The experimental units are the workers who are assigned to these three different production methods. Now the type of study here is experimental because the workers are not, by a priori, they are not available, they are not working on these three different methods on their own. So we randomly made the assignments as a part of this experiment, and therefore this is an experimental study. So now let's look at the notations. So we have three populations: the production per week for assembly method A, production per week of assembly method B, and method C. Those are the three populations. And mu sub 1 is the mean production per week of method A, or treatment A. And mu sub 2 is for method B, mu sub 3 is for method C. And the variance of production per week of these three methods A, B, and C are given as sigma 1 squared, sigma 2 squared, and sigma 3 squared. Okay. Now these are unknown, so we want to test whether the three means are all the same, or are there any difference among these three means. And in order for us to be able to do the test, we need these three assumptions. So the weekly production are normally distributed for each of the three methods, and the three population variances are the same, common variance, and the worker production are independent. Production of method A does not affect the production for method B or method C, and so on. And this is the sample information. So n sub 1 is the sample size for method A, n sub 2 method B, n sub 3 method C. Then x bar sub 1, x bar sub 2, x bar sub 3 are the three sample means, and s sub 1 s squared sub 1, s squared sub 2, s squared sub 3 are the three sample variances. Now we need to construct the ANOVA table and do the hypothesis test using a F test. So now let's go to the Excel file and do the test.